Hey guys, in this video we are talking about relative frequency tables. So basically relative frequency tables allow us to see the proportions. So the frequency table, which is this one, just tells us how many, but the relative frequency tables lets us see, okay, kind of what percent. So it's a little bit more useful for data analysis. Anyway, let's go ahead and look at the question. The two-way frequency table shows data on Quidditch goals blocked when a goaltender was using a luck potion or a placebo. In case you don't know, this is a Harry Potter reference, and it's not called a goaltender, it's called a keeper. Anyway, let's go ahead and do the question. So, let's look at this. So we're given the frequency table and we need to make the relative frequency table. So it's telling us that the row total needs to be 1, and that's always going to be true, or 100 if you're doing it in percents. So this is going to be in decimals because they need to equal 1. And they're having us do it to the nearest hundredth, which is fine. Okay. So basically, we need to add up this row and see what we get. So if we add up this row, we're going to get 53. 53. So there's 53 total blocked goals. And let's go ahead and add up this row while we're here. So that is going to be 12. Nope, it's not 12. It's 13. Silly me. 13. Okay. So this spot is going to be this number divided by this number. Okay, so it's the percent of placeboed keepers that blocked, or I should say the percent of blocked goals, because that's the total we have. The percent of blocked goals that were placebo, where the keeper was placeboed. So the percent of blocked goals, because that's what we totaled, was blocked goals. The percent of blocked goals that was where the keeper was placebo. So that's 30 divided by 53. 30 divided by 53 is 0.566. So it's to the nearest hundredth, so that's going to be 0.57. So, oh, they want it to be a proper fraction. Okay, never mind. It says nearest hundredth. Figure yourself out, Khan Academy. Okay, apparently it wants a fraction. It's not expecting that. So this is going to be 30 over 53. It's way more useful looking if you have a decimal, but whatever. I don't think we can reduce that. Yeah. Anyway, so then this one is going to be the other number, 23 over 53. So 23 over 53, which if the last one was about 57%, then this should be about 43%, which is not a big difference. It's pretty negligible, actually. So of the blocked goals, most of them were placebos, not luck potions, but it's negligible, like I said. This is going to be 8 over 13. 8 over 13. And this is going to be 5 over 13. So just because I'm curious and I want to know what the percentage is, 8 over 13 is 61.5%. I'm going to call it 62%, even though that's majorly rounding, but just for ease of math. So 62%, which means that this one is 38%. So again, more not blocked goals by placebos than by luck potions, which is interesting. Anyway, I think there was just more people who were placebo than, or more goals to the keepers that were placebo than the luck potion. So that's why it's showing up that way. Anyway, yep. So that's how that works. You're basically just taking this number, dividing it by this number, and where they put these tells you which direction to do the adding. So this is the percent of not block goals that were placebo, the percent of not block goals that were luck potion. If the ones had been down here, right? If the ones had been down here, then it would be the percent of placeboed people that didn't block, that blocked goals or didn't block goals, and then the percent of luck potion people that blocked goals or didn't block goals. You see the difference? So it's a little weird, but these ones are basically telling you which direction to do the adding, whether it's right, left, or up, down. Okay. Yeah, so this one would be the other direction, right? This one looks like it would be decimals. So I want to do it just because I want to do the decimals. Okay. So Comden is a mind-reading alien. They just really like the fantasy sci-fi stuff in this section. Anyway, he had each friend draw and look at a card. Then he guessed whether the card had a star on it. In a two-way frequency table, we have the data. Okay, so we are going to add in this direction because the ones are down here. So we're adding in this direction. So we have 5 and 754. Way more times it wasn't a star. He only got it wrong 3 times. That's interesting. Okay. Switch to the mouse. All right, so this one is going to be 4 out of 5, or 0.8. 0.8. And then this one would be 1 out of 5, which is 0.2. I know it says nearest hundredth, but you could write a 0 there, I guess. But yeah. Yeah. Then 2 out of 754 is 0.002. Khan Academy is really not making this easy. 0.0026. So it says nearest hundredth, but if I did that, it would just be 0. I'm going to see what Khan Academy thinks about this. It might get mad at me. We'll see. And then 752 over 754 goes here, and that would be 0.997, which is really just 1. Don't like this. I'm going to see what Khan Academy says. It's probably going to get mad at me because I'm not following instructions. But I'm really curious to see what Khan Academy. Oh, it liked it. Now I'm curious to know what it would say if I put 0 and 1, which I didn't do because I feel like that's wrong. But based on rounding to the nearest hundredth, that would be right. 0 and 1 would be rounded to the nearest hundredth, oddly enough. But they're not correct because it's not like this never happened. So I would have to do it this way. So weird thing, but yeah, if you're gonna have to round to 0, just keep going to more decimal places until you have something to round to. Don't just round to 0. I'd be interested to know what Khan Academy would do if you did, but please don't. Yeah, because that's wrong. It would be wrong to put 0 there because it's not like it happened 0 times. Okay, glad I did that example. Yeah, and so then this would just be the same thing. All right, so that is creating two-way frequency tables. So let's talk about reading them. So you're given this is not a relative frequency table. This is just a frequency table. So this would be more like steps in creating the frequency table, because it's asking you what fraction are male. So you're given a frequency table, not a relative frequency table. This is a regular frequency table. You're asked what fraction are male. So you want males out of the total. So total males out of the total. So total males would be 90. Total is 200. So it's 90 out of 200. Does that make sense? So total males divided by total. What percent of students were male? Again, so this time instead of a fraction, it's a percent. Round to the nearest percent. So what fraction are male? So 37 out of 100. So again, nope, that's flight. Male. Total male is 50. Total is 100. So 50 out of 100. So 50%. If this hadn't been 100, you can do that in a calculator. But since it's 100, you don't need to. Yeah, so 50 out of 100, 50%. Yep. Let's see here. I'm looking to see if they have different types of questions. It doesn't look like it. What fraction of English teachers have at least 5 years of experience? So at least 5 would be not less than 5. So not in this column. English teachers, but not this column. It'd be these two columns. So it's not the total. It's adding these two together. So 11 English teachers out of the total 15. So what fraction of English teachers? So your total is the number of English teachers. And then at least 5 years of experience would be these two columns. So 9 plus 2 is 11. 11 out of 15. Approximately what percent of graduates? This is the same type of deal. So you guys can figure that out. Okay, so that is relative frequency tables. Pretty harmless. Okay, cool. Let me know if you have any questions, and I'll see you in the next video.